Hello, and welcome to this week's edition of My Strange Addiction.
Why do you sound like a game show host? We have like really serious problems.
This week, we'll be looking at patients who are suffering from one addiction: calculus.
What's calculus?
So what is calculus? Well, calculus is the branch of mathematics that deals with the properties and findings of integrals and derivatives of functions.
That's good, it's good!
First, we have Denise.
Hi, my name is Maxwell Mejia. I'm 18 years old, and one fun fact about me, I only eat ice cream when it's on fire.
Wow, truly fascinating. So, what's your addiction, Max?
It's pretty normal. I'm addicted to finding the volume of washers, and if I get a problem wrong, I throw myself into a washer. And set it for 2 hours so no one can see my shame as I cry out loudly into a pair of pants.
Next up, we have Tommy.
I just need a squeeze!
Tommy is, of course, talking about the squeeze or sandwich theorem in calculus.
It was made in modern terms by Carl Friedrich Gauss for a given interval containing point A where f, g, and h are three functions that are differentiable, and g of x is less than or equal to f of x, which is also less than or equal to h of x over the interval. Then, if the limit of L of g of x equals the limit of L of h of x as x approaches a, that must also be the limit of f of x, or otherwise known in math terms as this.
So Denise, I take it you're also addicted to calculus.
Count. Yeah. Are you an idiot? Don't you know I'm the best user in the whole freaking house? And there are like 3 whole other people besides me in the house? That's impressive.
So Tommy. Tommy, can you explain to us what the history is of your sandwich addiction?
Well, one day, there was bread. I just had to make a sandwich.
How did that turn into calculus? Oh.
Then, in calc class, we talked about the sandwich theorem. And I was hooked. And I gotta make sandwiches. I just gotta squeeze.
So, Max, what is the history of your calculus addiction?
I had this really cool teacher senior year named Miss Julia Ani, and basically we started learning about the area between two curves, and then I got more serious with the volume, and then we got into washer problems, and I just couldn't stop. It was just so exhilarating to find the answer to the problems.
Wow.
And to make my teacher proud.
Thank you for sharing.
You cut me off a lot.
That's
Find the volume of the region defined by x equals 4 and y equals 2. Okay. Child's play. Volume is equal to the integral from 0 to 2. Make sure you put the pi outside, because you really need that. The first line is 4. You square that minus the second line, which in this case is x squared. You square that and then include a dx. Can I solve more? I need to solve more.
No.
I need to
No.
solve.
No. Someone stop him.
I need to
Someone
solve
stop
more.
him.
I need.
Denise, you need to know your place, Denise, okay? You're the one with the addiction. I'm the therapist person, trainer, /
You're a hoe.
I'm asking you
Like you're
very nicely what the history of your calculus addiction is. You need to go back before you can go forward. Do you understand? Don't answer that, it was a rhetorical question! Tell me, Denise, where did it all begin?
It all started in elementary school when I really liked the letter U. And then I showed people how to write it, but they said it was wrong. And then I said they're idiot heads. And the teacher pulled me aside and sent me to the principal.
Ever since my AP Calc teacher taught me the squeeze theorem, I just couldn't get enough of it. I have to use it all day, every day. But now, I have to squeeze people endlessly until they know the theorem. Say the theorem!
I don't know it!
You have to!
Oh my god, this is just like an x-axis. I have to rotate it. Ah! Washers, 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 washers.
Washers, 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 washers!
X equals U. Because U is the answer to everything. Which means dx equals U. Which means 2 equals U. Which means the answer x equals U2. Which is a good band, by the way.
Denise, what are you doing?
Use substitution.
You idiot! That is not how you solve this problem.
Yes, it
Give
is!
me the chalk
No!
now!
You're ruining it!
No, I'm not! U should be equal to x squared plus 2. See?
Where are you
And
getting
then-
these big numbers?
I don't know. That means du is equal to the derivative of this amount, which happens to be 2x dx. You set it equal to dx, which is equal to du over 2x. You also have to plug in the new u values. So...
Keep going. Jesus, Max, you better know how to do this. Max! You plug in that. You see that right there where it says dx equals that? You plug in that over there. Yes, do it. Plug that in for
No, you have
dx.
to make new u values because
Oh
you're
my God.
using wait.
Yeah, we're not
No,
gonna say it.
you don't have to do that. That's not what you have to do at all.
first.
That's not this
I'll
type
do
of
it
problem.
again.
Plug in
It
you.
is.
You
It is
plug
the
in
same
u for that. You say you do x radical u. Oh my God, I'm taking over. I'm taking over. Okay. So Tommy, when you're back and editing this later, this is where you take off from. Okay. So what you do is you see how it's dx equals du over 2x. That's that dx. So what you're gonna do is you're gonna change that dx to du over 2x. So we're gonna rewrite our equation right up here. Here's the integral from 0 to 4 parentheses. I mean not parentheses. That's just x.
I don't know.
Radical u. And then remember, instead of dx, what we're putting is du over 2x. Now we have the x there and the x there, so we can cross those out. And now we can just take this 1/2 here and pull it to the outside of the integral. So we're gonna rewrite our final equation over here as 1/2 integral from 0 to 4 radical u. And now all we have to do from here is take the integral of radical u, which is u to the 1/2. So we're gonna do u to the 3/2, and then that's gonna be 2/3. And then we have to go back and plug in for u the x squared plus 2. So, you get the point from here. That's basically how you do it.
My phone.
It worked.
Hey, what's up? We're here today with Maxwell Mejia. He's gonna tell us a little bit about himself,
That's not how it starts.
his
Stop.
the life and times of Max Mejia. So, what do you have to tell us today, sir?
Well, I know how everyone's gonna die.